हेलो एवरीवन, कैसे हो आप सभी लोग। आई होप सब अच्छे होंगे। सो टुडे आई एम बैक अगेन विद अ लेक्चर on the topic of vector and 3D geometry. So in today's lecture we're going to discuss very important topic of the concept of scalar triple product. Now scalar triple product जो concept है, it is basically used in many places of 3D geometry, even in vector calculus and even in vector algebra. Okay, so scalar triple product का जो concept है उससे हम लोग पैरेलल कोप्लेनर वेक्टर्स का एनालिसिस कर सकते हैं. इवन वी कैलकुलेट दिस पर्टिकुलर कॉन्सेप्ट एंड टू एनालिसिस द कॉन्सेप्ट ऑफ वॉल्यूम ऑफ 3D figures like parallelepiped. Okay, so with this I will start with the today's topic of scalar triple product. Okay, so my name is Sirsha and I am a BTech student at IIT Kharagpur. So today's goal will basically to study about the scalar triple product, and even after doing the scalar triple product we'll move on to the study the properties and the questions regarding it. Now before starting with today's topic I want to take a few questions to illustrate my previous lectures. Okay, so before starting this today's lecture I'm gonna take up concept and the topics questions which is basically on the topic of scalar product and vector product. Okay, so I hope आप इस लेक्चर को डायरेक्टली ऐसे नहीं देख रहे होंगे, आप लेक्चर को प्लेलिस्ट फॉलो कर रहे होंगे, एंड वंस आफ्टर यू आर वाचिंग द प्रीवियस लेक्चर देन ओनली कम एंड वॉच दिस पर्टिकुलर लेक्चर. सो विदाउट वाचिंग द लेक्चर इन कंटिन्यूएशन डू नॉट कम एंड डायरेक्टली मूव ऑन विद दिस पर्टिकुलर लेक्चर. आई होप this was clear. Okay, so with this let me get started with the question, and this is the first question that basically on your screen. Okay, so ये जो question है this basically was asked in JEE Mains 2020. Okay, the era of COVID. Okay, so basically this particular concept is basically an important concept which basically relates the question of dot product with the concept of trigonometric equations. Okay, so the first trigger movement to use the concept of dot product basically when you see this word, the angle between the two vectors, that is basically this vector and this vector. So very first moving forward you are given with the equation in the question, that is a square plus b square plus c square is basically equal to 1, such that a, b and c all belongs to real numbers. Okay, so from here if I say this particular vector as a1 vector as ai cap plus b j cap plus c k cap. Similarly a2 vector, if I say this particular vector as a2 vector as bi cap plus cj cap plus a k cap. So from here if I try to compute the angle between the two vector, what can I apply? I apply the concept of dot product. So from here if I say a1 dot a2 divided by modulus of a1 vector into modulus of a2 vector. So from here if you calculate the result, so from here what you can see, the modulus of a1 vector and modulus of a2 vector are equal, because the components may be different but they have actually the same number. So when I am actually taking the modulus value of basically a1 vector and the modulus value, that means the magnitude of a2 vector, they basically comes out the same, and that is basically root under a square plus b square plus c square. And we already know that a square plus b square plus c square is equal to 1 as it is mentioned in the question. So from here the value will be 1. So if you compute this particular dot product such that this result will be ab plus this will be bc plus this will be ac divided by 1. So from here you can compute the result of basically the result that you from here you will get basically is actually cos theta is actually related as ab plus bc plus ca. So from here if you try to solve in the terms of the equation that is also given information is basically a times of cos of theta is equal to b times of cos of theta plus 2 pi by 3 and also equal to c times of cos of theta plus 4 pi by 3. Okay, so if these three conditions are basically equal, and let me equal it to some scalar value, let that be lambda. So from here I can do one important thing, that is I can take a, b, c common out, and in doing so I have to multiply with 1 by a plus 1 by b plus 1 by c. So from this particular scenario if you try to calculate 1 by a, it will basically will be cos theta by lambda. Similarly 1 by b will basically will be cos theta plus 2 pi by 3 divided by lambda. From here again 1 by c will basically will be cos of theta plus 4 pi by 3 divided by lambda. So from here if you put the value of cos theta as a, b, c, and 1 by a, 1 by b and 1 by c has a term which is lambda as common, 1 by lambda as common. So from here if you put this you will get the result as cos theta plus of cos of theta plus 2 pi by 3 plus of cos of theta plus 4 pi by 3. So from here, if you apply the trigonometric identity of cos A plus cos B, cos A plus cos B is basically equal to 2 times of cos of A plus B divided by 2 into cos of A minus B divided by 2. Okay, so from here, if you compute the cos theta value, that is basically ABC divided by lambda times of cos of theta plus 2 times of cos of, that is theta plus theta, that 2 theta, and 2 pi by 3 is basically 120 degree, and 4 pi by 3 is basically 240 degree. So 120 plus 240 is basically 360, that is 2 pi. So from here I can write it as theta plus pi, because 2 theta plus 2 pi divided by 2 and 2 get cancelled, and this particular will be again, and from here theta get cancelled. In the taking the negative, that A minus B by 2, the theta will get cancelled, and in doing so the result will be 2 pi by 3, because it get cancelled with 2. So from here, if you see this result will be ABC divided by lambda plus of, and from here if you see this particular term, this basically theta plus pi. So we know that whenever in trigonometric function, whenever any angle is basically added with a integer multiple of theta pi, then in that situation the trigonometric identity remains the same, but they get changed only by the sign convention. So from here, if we see theta plus pi, this basically goes in the, this basically, because pi is this particular angle and plus theta, so it basically lies in the third quadrant. So from here you can see this particular angle lies in third quadrant, and in third quadrant cos is basically negative. So cos is negative. So from here we get the relation, that is times of cos theta minus of 2 times of cos of theta into, and pi by cos of pi by 3 is basically half. So from here this half get cancelled, and from here you can see cos theta minus of cos theta, which gives the result as 0. So from here what you can say, that basically in doing so the cos theta value comes out to as 0. Now if cos of theta is 0, then what you can comment on the angle between the two vector, that is basically 90 degree, that is pi by 2. So from here you get the right answer to the question is basically option number D. I hope this particular concept was clear, and this very simple types of question that is basically repeated many times in the JEE mains examination. I hope you will take care of this particular questions. Okay, so with this let us move to the another example on basically the previous lectures. Okay, so in this question it is basically said that there are 3 vectors such that modulus of, that is magnitude of A vector and B vector and C vector is basically equal to 1. That means they are unit vectors. Okay, so it is said that A, B, C are basically 3 unit vectors such that they satisfy this particular relation. That means these 3 vectors actually form a triangle. And from here in this particular relation it says the lambda is basically this particular dot product, and another vector is D defined as such that the mutual cross product values. Okay, mutual cross product, and then they are adding it. So in the question it is asked to calculate the order pair lambda comma D vector. So from, if we calculate the question, if we try to solve the question from the given equation, that is A vector plus B vector plus C vector is basically equal to 0 vector. And this particular condition implies that these vectors makes up a triangle where the arrows are directed towards each other. So if this is A vector, this is B vector, this is C vector, then these 3 vectors form a triangle, form a closed triangle. Okay, so from here if I do one important thing, such that I take this particular vector and I square these particular vectors. So squaring this particular vector does simply implies that taking dot product with this particular vector. So on the LHS side it will be square of this particular vector, and on the RHS side it will be null vector dot this A vector plus B vector plus C vector, which is also equal to 0. Okay, so from here you will get the result, that is basically mod of A square plus mod of B square plus mod of C square plus 2 times of A vector dot B vector plus B vector dot C vector plus C vector dot A vector, and which is equal to 0. So from here you see these all are vectors are unit modulus, so this value will result in 3. So from here you can say the value of lambda is basically equal to minus 3 by 2. Okay, you take this particular on this particular side and then you compute the result, the value of lambda will come out to as minus of 3 by 2. Now, and from again in the second equation, if you solve and try to get to the result of D vector in terms of A vector and B vector, because in the options you see that is basically in terms of any of the 2 vectors, that is BC, AB or AC. So if you try to compute this particular result in terms of AB vector, let me see what the result we get. Okay, so this is basically the vectors are given like this. So from here I can do an important substitution as A plus B vector is basically equal to minus of C vector. So if I put in place of C vector I put minus of A plus B vector, then I can get the D vector in terms of A vector and B vector. So because we see in the options, if we try to eliminate the option, this particular option can never be the answer, this particular option can never be the answer, so only these particular two cases are left out. So in these two particular cases, what we see, basically the D vector is expressed in terms of C vector or B vector or A vector or B vector. So we are solving for this particular case where the D vector is expressed in terms of A vector and B vector. I hope this result is clear. Okay, so from here if we go on and solve, I will get the first vector as A cross B vector, and the second vector I will get it as B cross minus of A vector minus of B vector. Similarly, and from C vector I can write this as minus of A vector minus of A vector minus of B vector cross C vector. Okay, so from here if you simplify the relation you will get A cross B vector. Okay, now if you simplify this relation, this will be minus of B cross A, which is same as plus of A cross B. So I can write it as plus of A cross B, and similarly B cross B is basically 0, and from here if you see, sorry, this will be actually cross A. Okay, this will be cross A. So this will be cross A. So from here if you take the cross product, A cross A is basically 0 and minus of B cross A is basically equal to plus of A cross B. So from here I can also write it as plus of A cross B. So this particular result gives me the result which is 3 times of A cross B. Okay, so this is basically the result, that is 3 times of A cross B, and from here we get to the right answer to the question is basically option number C. I hope you have understood this particular question, and this was very simple question. Now with this, let us start with the today's topic of scalar triple product. So how is scalar triple product defined basically? So scalar triple product, by the word triple, that means there will be 3 vectors involved. Okay, there will be 3 vectors which is involved in the products. So in previous study what we saw that basically in dot product or scalar product, dot product or the vector product, basically there was 2 vectors which was involved in the result. Similarly, if there are 3 vectors which are involved in that particular scenario, we calculate triple product as scalar triple product and vector triple product. So firstly we will study about scalar triple product. Okay, so अगर 3 वेक्टर दे रखा है, for example we are having the 3 vectors as A vector, B vector and C vector. Okay, so then I can define the scalar triple product as such quantity. Then the scalar triple product is defined as such quantity, that is A cross B. Okay, this is A cross B, this particular vector taking dot product with C vector. Okay, so this particular result is actually known as scalar triple product. Basically with the first 2 vectors, पहला जो 2 वेक्टर है उस 2 वेक्टर्स का अगर वेक्टर प्रोडक्ट लेते हो and then the result will be vector, and simultaneously you take a dot product with the another vector to get the result as scalar value. Okay, so in that particular scenario you will get the result with scalar value, and this particular scalar product is actually represented by box representation of A vector, B vector and C vector. I hope this representation is clear. Okay, so now with scalar product, actually scalar triple product basically has some geometrical interpretations. Okay, some geometrical interpretations. I hope you are taking out running notes of this particular lectures. Okay, आप एक रफ कॉपी और पेन लेके बैठ जाओ लेक्चर को देखने के पहले, ठीक है. गो ऑन सॉल्विंग द क्वेश्चंस विथ मी एंड साइमल्टेनियसली टेक आउट रफ रनिंग नोट्स. ओके, रनिंग नोट्स लेते चलो ताकि आप अंडरस्टैंड कर पाओगे कि लेक्चर में चल क्या रहा है. ठीक है, सो विथ दिस इज अ ज्योमेट्रिकल इंटरप्रिटेशन. So what is the basically the geometrical interpretation of scalar triple product? Okay, so what we actually say about scalar triple product basically is whenever we have a 3 vector such that पहला 2 vector का vector product लेते हैं and then we are taking a dot with the third vector, then that particular case is known as vector triple product, scalar triple product. Okay, why I am taking vector the name. Okay, so that is known as scalar triple product. Okay, so what does the geometrical significance means? Before talking about geometrical significance, let us draw a 3D axis. Okay, the XYZ axis. So why do we need the XYZ axis basically? So if this is XY plane and that these 2 vectors are basically in the same XY plane. Okay, these 2 vectors are basically in the same XY plane such that this vector B is a vector is oriented along the X axis and vector B is oriented along the Y axis. Okay, now in this particular fashion, if we take the vector product of A and B, the resultant vector will be along the direction which is perpendicular to both the vector, that is along this particular direction, that is A cross B. Okay, So in doing so, you will get a vector which is along this particular direction, and let there is another vector that is basically c vector, okay, which is basically in this particular plane, okay, which is basically in this particular plane. And in this particular doing result, what we get, we basically form basically a 3D figure. So if we try to complete this particular 3D figure, so this particular 3D figure basically, okay, this particular 3D figure is also known as parallelepiped, okay. This particular 3D figure is also known as parallelepiped, okay. So in this parallelepiped, what we see an important result, that is that the three vectors are basically coterminous vector, and all these three vectors basically represent the edges of this parallelepiped, okay. So what we talk about is basically the scalar triple product. अगर scalar triple product का बात कर रहे हैं तो basically जो that is basically represented by dot, a box of this, and this particular box can be expanded as A cross B dot product with C, ठीक है. So from here what we can say that A cross B is basically this particular will lie on this are lying on the x and y axis. So if A and B are lying on the x and y axis, and if I take this A cross B, so what can I say about this? Now if I take the A cross B vector, that is basically represent the area of this parallelogram, and in the doing so, this particular actually represent the area vector of parallelogram, okay, area vector, okay, area vector, because this particular result is a vector result of, and which the direction will be given by the A cross B, okay. So whenever we talk about area vector, the direction of area vector is basically for a free surface is basically given in two direction. For example, we have a plane such like this, and if we talk about this area vector, okay, so the magnitude of the area vector will basically equal to the magnitude of this 2D figure, and but the direction of this vector can be in two possible directions, that is in this particular direction also and in this particular direction, unless and until it is mentioned in the question in which sense of rotation it is implies. Then you will, if it is mentioned the sense of rotation, the sense of direction is basically implied in this particular this area vector in this particular area, then you will take the direction of the area vector is along the by the right hand rule. How by right hand rule? You have to take take your thumb, and in the direction in which the arrows are showing, you have to curl your palm in this particular fashion. That is basically it is moving in this particular direction. If you are looking from here, this particular going in the anti-clockwise direction, and in doing so, in moving in the anti-clockwise direction, you get your thumb which points toward this particular side, okay, your thumb points toward this particular side. So in doing so, you will get the area vector ka direction jo hai, that is basically the unit vector of this area vector, okay, unit vector of the area vector will be point toward this particular direction. So this particular direction will be rejected, but unless it is mentioned in the question that which direction or in oriented area is given, you cannot directly say what is the direction of area vector. But in this question, if we talk about this particular parallelogram, say this is O, this particular point is A, this is B and C. So from here OAB is a parallelogram, and this parallelogram has the area A cross B, okay. So this will be area of the parallelogram, okay, OABC, and this particular is taken dot product with C. So what we get to the result is basically the area, the cross product will be lying on this particular direction. So and if this result is this particular angle is basically represented as phi, the angle between the z axis and the C vector is basically represented as phi, then in doing so I can simplify this result also as area of this parallelogram OABC times OABC, basically modulus of this area of parallelogram OABC into modulus of C vector into cos of phi, okay, into cos of phi. And another important result will be there, basically if you take this area of a modulus, then there will be the vector modulus of this particular unit vector, that is basically in this particular orientation. So if I represent the unit vector along this perpendicular to A and B vector as neta unit vector, then that term will also be encountered in this particular question. So from here, if you go on and solve this, basically the area of the parallelogram OABC times the vector C. So vector C is basically, and vector C modulus times of cos of phi is basically the projection. If this is the projection length on that particular y-axis, so from here you will actually get to the result, that is from here if I say this particular result as L, this particular point as L, so from here OC cos phi is basically equal to OL, Okay, so if this is an OL, so this is basically represent the height of this 3D figure, the height of this 3D figure. Okay, the height of the 3D figure, that is whose base is a parallelogram and whose height, and this particular OL basically represent the height of the 3D figure from the base of that parallelogram. Okay, from the base of the parallelogram. Okay, so if I write this height of the 3D figure, so and this particular quantity is some quantity that is area, and this particular quantity is some quantity of length. So what can you say of this? So if it has dimension of meter square and this particular has dimension of meter, so if you multiply them, then you will have dimension of meter cube. So meter cube dimension is basically dimension of volume. So from here you will get the basically the volume of this 3D figure, that is the volume of the parallel pipe. Okay, so this particular 3D figure which is formed such that the base is a parallelogram, that particular 3D figure is known as parallel pipe. So you will get the volume of the 3D parallel pipe whose coterminous vectors are given with the edges of this parallelepiped. Okay, with coterminous vector, okay, with coterminous vectors as A vector, B vector and C vector. So from here you get a very important result that you have to apply in most of the question, that is the volume of any particular parallelepiped whose coterminous, whose edges are given by, whose adjacent edges are represented by vector A, B and C, then that particular volume of the parallel pipe is basically given out by the scalar triple product of that particular vectors, of the three vectors. So I hope this particular result is clear. Okay. Now the question comes to us how to calculate the scalar triple product. Okay, now for doing so we have to study about the properties of scalar triple product. तो चलते हैं, शुरू करते हैं properties of scalar triple product. Now very first property that we are going to be studying in this particular with the starting is basically A vector, B vector and C vector are basically cyclically permuted. Okay, they are actually cyclically permuted values of, they are cyclically permuted the values of scalar triple product. Okay, and by short, scalar triple product also represented by STP. Okay, scalar triple product, this is not what you think standard temperature and pressure, this is basically scalar triple product. Okay, and then the triple product remains the same. So what do I mean to say? If you basically cylindrically rotate that particular vectors in such fashion, then you will get the result of the scalar triple product which is same in all the cases. That means if you take the box product or scalar triple product of A, B, C vector in such fashion that A comes first, B then C is basically also equal to, if you move C over here, if you move B over here and C over here, and in doing so A over here, that means there is even number of changes. Okay, that is even number of changes. Now by this you must have sensed why the even number of change is giving the same result. That means it has something to do with determinant. It has something to do with determinant, because in determinant when we do even number of changes with any row or any particular column, then we get the result of the determinant which is same. But if we do odd number changes, we get the result which is differ by that only a negative sign. So this particular result can also be written as scalar triple product of C, A and B. Okay, so this is the very first property, and I hope this particular property plays a very important role. But in doing so, if you have an odd number of changes, okay, okay, if you do by mistake, if you take odd number of changes, then you will get the result which basically differs only by a negative sign. So for example, if you calculate the box product of this A, B, C vector is basically negative times of, for example, in place of A you replace it with B, then it will be B, A and C, then it will be represented, they will be related with a negative sign. I hope this particular result is clear. Which is also negative times of, if in place of A you replace it with C, then it will be C, B and A vector. So this will be again be equal with the negative sign. I hope you will take clear of this particular property. Okay, now the third property basically talks about, that was the second property. Okay, this is the second property and this is the third property. So the third property talks about in scalar triple product of the position of the dot product and the scalar product can be interchanged. Okay, the position of the dot product and the cross product can be interchanged. That means I mean to say that if I have this scalar triple product, that is A, B, C, then in doing so, if I take the vector product of A, B first and then dot with C, this particular result is also equal to, you take a dot of B cross C. Okay, you take A dot with B cross C. Now this particular result is also same result. Okay, this particular is the same result. Okay, it doesn't matter why you put this particular bracket. Okay, but in the position of this dot and the cross actually can be interchanged. Okay, the position of the dot and the cross can be interchanged. Okay, Now we talk about the fourth property. This is basically whenever in place of vector ABC we are having a vectors which are multiplied with some scalars, the where, now if I have scalar like lambda, mu and basically new vector which are basically scalar values. Now if I have are given with this particular vectors lambda times of a vector, mu times of b vector and nu times of c vector, then this categorical result can also be written as taking the scalar as a product in outside, that is lambda mu nu into scalar product of a vector, b vector and c vector. Okay, so this is the fourth property and the important property. Now the fifth property actually talks about that if we are given with the four vectors, a vector, c vector and d vector, they are basically the four vectors. And if I take the scalar triple product in such fashion that any one of the vector is represented as sum of two vectors and this a vector and d vector, and this particular scalar triple product can be written as plus summation of two scalar triple product. Okay, this can be written as summation of two scalar triple product. Now this particular scenario actually comes from the use of determinants. Okay, use of determinant. Now determinant में कोई भी एक रो या फिर कोई भी एक कॉलम में अगर एडिशन करके एलिमेंट्स लिखा होता है तो वी कैन स्प्लिट इट अपार्ट इन टू फॉर्म ऑफ डिटर्मिनेंट. सिमिलर द केस गोज फॉर द स्केलर ट्रिपल प्रोडक्ट. सो अगर एक भी वेक्टर कोई दो वेक्टर्स के टर्म में लिखा हुआ है, देन इन दैट केस वी कैन स्प्लिट दैट ए वेक्टर c vector over here and d vector, and similarly b vector, c vector and d vector over here. So this particular scenario relates the condition of addition of two vectors in the form of scalar triple product. I hope you will take this particular scenario in mind. Okay, so with this let us move to the sixth property. This is a very important property, like how to calculate the value of scalar triple product. So for example, we have the a vector, b vector and c vector in their components form. Okay, in the component form I mean to say that the components are given as in terms of I cap, j cap and k cap. Now in order to calculate the value of the scalar triple product, you just have to compute the value of the determinant such that the first row is formed by the individual component of vector a. Similarly, the second row is formed by the component of vector b, and the third row is formed by the component of vector c. Okay, now if you compute this particular determinant value, then you will directly get to the result of the scalar triple product. I hope this particular condition is very important and clear to all of you. Okay, now on basis of this, there was an important question that was asked in JEE Advanced. Okay, in IIT question paper of 2009. Okay, so if the question was basically said that to calculate the volume of the parallel piped whose adjacent edges are given as I cap plus j cap comma 2j cap plus I cap comma I cap plus j cap plus pi times of k cap. Now ये वाला जो क्वेश्चन दे रखा है, there are three vectors which basically represent the adjacent edges of a parallel pipe. So in doing so, if you have to calculate the volume, that means directly you have to calculate the vector scalar triple product of these three vectors. Okay, अब जब वेक्टर्स जब डिटर्मिनेंट वैल्यू जब निकालोगे ना, तो बी वेरी कॉशियस अबाउट राइटिंग द कॉम्पोनेंट, इंडिविजुअल कॉम्पोनेंट इन इंडिविजुअल प्लेसेस ओनली. लाइक आई कैप का जो कॉम्पोनेंट ऑफ वेक्टर ए, यू शुड राइट इट ओवर हियर. सिमिलरली जे कैप का कॉम्पोनेंट ऑफ हियर शुड बी हियर. सिंस जीरो द के कैप कॉम्पोनेंट इज जीरो. सिमिलरली इस क्वेश्चन में देखो आई टू जे कैप इज रिटन फर्स्ट एंड देन आई कैप. सो डोंट डू दिस मिस्टेक. डायरेक्टली राइट इज टू ओवर हियर एंड वन ओवर हियर. डोंट डू दिस पर्टिकुलर मिस्टेक. आई कैप का कॉम्पोनेंट इधर लिखो 1 and 2 and 0 and here 1 and pi. Okay, so from here if you compute this particular determinant value, you will get to the volume is basically pi times of 2 minus of 1, that is basically pi cubic units. Okay, so the result will be pi cubic units. I hope you will remember this particular result of volume of parallel pipe as basically is equal to this, in this result is given as pi. Okay, so this was the basically the question that was asked in a paragraph form in the IIT paper. Okay, in the IIT paper of 2009. I hope you will keep this particular thing in mind. Okay, so with this let us move to the seventh important property, that if we have a vector, b vector and c vector are basically coplanar vector. Okay, so if all three vectors are basically coplanar vectors, that means they all lie in the same plane. Now if all of them lie in the same plane, if all of them lie in the same plane, then what can we comment on this particular volume of the parallelepiped? Then you will say that since C also lies in the same plane of A and B, then that means the height of the parallelepiped will be 0. So if the height of the parallelepiped is 0, then you can say the volume of this parallelepiped will basically be equal to 0. So from here you get a very important condition that you will see and take care to solve many questions in the upcoming results. That is, whenever you are given with the 3 vectors such that the 3 vectors are coplanar vectors, in that you will directly apply the result, that is a box product. उन तीनों का box product आप क्या कर दोगे, इक्वेट कर दोगे 0 से, क्या कर दोगे आप 0 से इक्वेट कर दोगे. I hope this particular result will be clear. Okay, so with this let us move to the 8th property. Okay, with this let us move to the 8th property. Okay, so before moving on to the 8th property, let us take up an example to illustrate my saying. Now this was another question that was actually asked in a IIT paper. Okay, here also it was asked in IIT paper of 2008. Okay, so in this question 2007 sorry, 2007 में ये ऐसा क्वेश्चन पूछा गया था जहाँ पर 3 वेक्टर्स देके उसको कोप्लेनरिटी का कंडीशन चेक करा रहा था. ठीक है, सो इन दिस क्वेश्चन इट सेज फाइंड द नंबर ऑफ डिस्टिंक्ट वैल्यूज. ओके, डिस्टिंक्ट ना वैल्यूज ऑफ this value this lambda such that the vectors minus lambda square I cap plus j cap plus k cap comma I cap minus lambda square j cap plus k cap comma I cap plus j cap minus lambda square times of k cap are basically coplanar vectors. So from here you can directly see the result. अगर 3 वेक्टर्स कोप्लेनर है तो व्हाट कैन यू डायरेक्टली आंख बंद करके एक चीज अप्लाई कर देना. अगर 3 वेक्टर कोप्लेनर दे रखा है, क्वेश्चन में बोल रहा है कि कोप्लेनर है, देन यू विल डायरेक्टली अप्लाई द रिजल्ट, दैट इज बेसिकली यू विल मेक द स्केलर ट्रिपल प्रोडक्ट एज 0 of the 3 vector as 0. And since we know how to solve this scalar triple product in form of component, if the vectors are given, then we directly have to solve this determinant. That is, there is minus of lambda square 1 and 1 minus lambda square 1 over here 1 and 1 over here and minus of lambda square, which will be basically equal to 0. Okay, so from here if I apply some elementary row transformation, आप देख पा रहे होगे कि मैट्रिक्स और डिटर्मिनेंट का कितना ज़्यादा इंपॉर्टेंस और यूज केस आ रहा है वेक्टर्स एंड 3D ज्योमेट्री में. तो हर एक जगह में देख रहे हो यू आर समवेयर और द अदर यू आर सॉल्विंग बेसिकली डिटर्मिनेंट वैल्यू ओनली. तो डिटर्मिनेंट का यूज केस वेक्टर्स एंड 3D ज्योमेट्री में है, इसलिए मैं वेक्टर्स एंड 3D ज्योमेट्री स्टार्ट करने से पहले मैट्रिक्स एंड डिटर्मिनेंट का टॉपिक मैंने पहले कंप्लीट कराया था. ठीक है, सो if you solve this by some elementary row transformation, or if you directly go and apply or expand this particular determinant along the first row, then you will get the result as this result will be lambda की power 4 minus of 1 times of this is minus lambda square minus 1. Okay, and this particular result will be plus 1 times of 1 minus of lambda square, that is plus of lambda square, and this will be equal to 0. So this result from here, the result will be minus of lambda की power 6 okay, plus of lambda square, and from here this will be plus of lambda square, this will be basically plus of 1 and plus of 1, this is plus of 2 and plus of lambda square, plus of 2 is equal to 0. So from here I get the result, that is lambda की power 6 minus of 3 lambda square minus of 2 is basically equal to 0. Okay, so from this particular question what we see is basically a polynomial of degree of 6. So from here if you simplify this particular polynomial equation, if we try to simplify this particular polynomial equation such that if I take lambda square common over here, I will get lambda की power 4 minus of 3 minus of 2 from here is equal to 0. Okay, or is equal, if I take 2 on this particular is equal to 2. Okay, is equal to 2 and I take lambda common from here. So in doing so you will also get, okay, in doing so you will get the results if you solve this particular conditions, and if you apply, or maybe you go on and try to find by hit and trial. If you put lambda is equal to 1, you will see that this particular root satisfy this particular equation. So if in doing so lambda is equal to 1 is one of the root of this particular solution, and if you go on and solve this particular by remainder method, then you will get this particular, if you factorize this you will get as lambda plus 1 ka lambda plus 1, okay, lambda square plus 1 ka whole square, lambda square plus 1 का whole square and lambda square minus of 2 is basically equal to 0. That means सॉरी यहाँ पर रूट 2 अगर सेटिस्फाई कर रहा होगा, ठीक है. सो यहाँ पर अगर रूट 2 पुट करके देखोगे ना तो बेसिकली रूट 2 विल बी सेटिस्फाइंग दिस पर्टिकुलर रिजल्ट. ओके, सो फ्रॉम हियर इफ यू सी द रूट 2 इज बेसिकली सेटिस्फाइंग दिस पर्टिकुलर रिजल्ट. ओके, So from here you will get to the factorization is basically lambda square plus 1 ka whole square into lambda square minus of 2, which is equal to 0. So from here you get the real value of lambda as plus minus of root 2, plus minus of root 2. So that was actually the question that was asked in the so it is asked also about the distinct number of values of lambda. So from here you can say that there are two distinct values of lambda, two distinct values. Okay, two distinct values of lambda is given present in the question. I hope you will able to factorize this particular polynomial. Okay, so this particular polynomial was actually given in the question because in JEE Advanced you have to actually you have to encounter some situation where you have to apply this particular scenario. Now अब अगर ये वाला अगर factorization नहीं भी कर पाओगे ना, then also you can do one important thing to get to the number of solution. Basically it talks about the number of real values of lambda. Okay, कितना real values of lambda हो सकते हैं इस possible solution का. So of doing this particular equation is basically you can take this particular question as a question of application of derivative. Now in question of application of derivative, basically try to plot this particular graph. Okay, try to plot this particular graph. For example, if I go on and say that you have an equation such that y is equal to x की power 6 minus 3x square minus of 2. So from here if I put a different equation and try to follow and try to get the graph. So from here if I try to get the graph, so from here if I put y at x is equal to 0, I will get the value of minus 2. So this particular graph at x is equal to 0 is minus of 2, and similarly if I put infinity, that this will tend to, if I put y का value at plus of infinity, then this particular result will also tend to plus of infinity because x की power 6 is the dominating term over here. Now similarly in place of x is equal to minus infinity, then the result also will be minus infinity, then the result will also be tend to plus infinity because minus infinity की power even power is basically plus infinity. So this will again tend to positive infinity only. Okay, so again if you differentiate this particular result, okay, if you differentiate this particular result, you will get the value as 6x to the power 5 minus of 6x, okay, minus of 6x. So from here if you take 6 common, it will be an x common again, it will be x to the power 4 minus of 1. So from here you will get 6x into x minus 1 into x plus 1 into x square plus 1. I hope this factorization was simple. This can be x square minus 1 into x square plus 1, and x square minus 1 can be expanded as x minus 1 and x minus 2, x plus 1. So from here you get the roots. Okay, basically if I try to find out the critical points, so from here if you try to plot the critical point, that will be basically 0, that will be basically 1, and then basically minus 1. So okay, so at this critical values we have to find the value. So for at 0 it is minus 2, let us put 1. Okay, so at x is equal to 1, the value will be 1 minus of 3 minus of 2, that is basically minus of 5, that is minus of 4. So at 1 the value is resulting in minus of 4. Okay, similarly at minus of 1 the result is 1 minus of 3, okay, minus of 2, again the result is minus of 4. So 1 also is this result is same. So from here the graph to the question, now if you see this particular, if you try to plot the this on the wavy curve, so the roots, the critical points is basically 1, 0 and 1. So from here if you try to draw the wavy curve, this is plus, and since these are all the odd powers involved and this particular result will be always positive, so we do not plot this on wavy curve method. So if we see this alternate plus minus sign will be there introduced. Okay, so from here you can see in minus infinity to minus 1, this function will be decreasing function. So from here I can draw this particular function as, so from here I can draw this particular function. Okay, so from here I can draw this particular function some positive infinity, because minus infinity में वैल्यू पॉजिटिव इन्फिनिटी को टेंड कर रहा है, तो पॉजिटिव इन्फिनिटी से डिक्रीज होते होते कहाँ तक आ रहा है, वैल्यू -4 तक आ रहा है. एंड सिमिलरली इस पर्टिकुलर -1 से 0 पे इंक्रीज कर रहा है एंड इंक्रीजिंग अप टू -2. सिमिलरली 0 से 1 पे अगेन इट इज डिक्रीजिंग, सो इट विल बी डिक्रीजिंग ग्राफ. कहाँ तक डिक्रीज कर रहा है, -4 तक, एंड 1 से लेकर इन्फिनिटी इट इज अगेन इंक्रीजिंग. सो दिस ग्राफ विल बी लुक लाइक दिस W फैशन. So this particular graph is a W graph. So from here you can see this particular graph has two number of real solution, because if we equate the y is equal to 0, that means the intersection of this particular graph with y is equal to 0, that means basically the x-axis, the x-axis has intersection point कितना है, there is basically two intersection, that means it has two number of real solution. So from here you can directly say that the number of distinct value of lambda is basically 2. I hope this particular particular question was clear. ये क्वेश्चन कितना ब्रिलियंट क्वेश्चन है, ठीक है. बेसिकली इट अप्लाइज अ सिंपल, देख के सिंपल लग रहा था कि क्वेश्चन में देख बोल रहा है कि 3 वेक्टर्स है, कोप्लेनर्स है, एंड आफ्टर सॉल्विंग दैट कोप्लेनरिटी कंडीशन वी एक्चुअली गेट अ पॉलिनोमियल इक्वेशन, एंड वो पॉलिनोमियल इक्वेशन बेसिकली हायर ऑर्डर का है. एंड वाइल सॉल्विंग हायर ऑर्डर पॉलिनोमियल वी डोंट हैव सम जनरलाइज्ड रिजल्ट, ओके, बट इफ वी ट्राई टू हैव सम जनरलाइज्ड रिजल्ट दैट इज बेसिकली इन टर्म्स ऑफ application of derivative. I hope this particular discussion was clear. If you do not understand the application of derivative part for now, you can directly remember कि इसका जो factorization होता है वो basically as lambda square plus 1 का whole square into lambda square minus of root 2 is basically equal to 0. Okay, आप डायरेक्टली इसको याद रख सकते हो, या फिर आप lambda is equal to root 2 अगर इसमें पुट करोगे तो 0 सेटिस्फाई कर रहा होगा. एंड अगर root 2 अगर कॉन्जुगेट है एंड बेसिकली ऑल द कोफिशिएंट आर बेसिकली रियल नंबर, दैट मीन्स देयर विल बी द कॉन्जुगेट ऑल्सो पॉसिबल फॉर दैट. सो अगर प्लस रूट 2 अगर एग्जिस्ट कर रहा है, सिमिलरली माइनस और रूट 2 भी एग्जिस्ट करेगा. ओके, सो फ्रॉम हियर यू गेट द कंडीशन द लैम्डा स्क्वायर इज इक्वल टू 2. सो अगर लैम्डा स्क्वायर इज इक्वल टू 2 पुट करके आप इसको सॉल्व करते हो, देन यू विल गेट द अदर रूट्स. ओके, सो फ्रॉम हियर यू विल गेट दिस पर्टिकुलर रिलेशन. ओके, और 6 डिग्री का इक्वेशन है, दैट मीन्स देयर विल बी 6 रूट्स to this particular polynomial. So from there to incorporate, if there are 2 roots already found out, there will be other 4 roots, and if we are knowing that particular other 4 root will be of imaginary term, then I can imaginary term and of magnitude is basically 1 of imaginary term, that is iota. So from here we can write this particular relation as well as. Okay, so I hope this particular question was clear, and this particular discussion is also clear, like how we actually get to the result कि कितना number of real number of solution होगा. Okay, I hope this thing is clear. Okay, so with this let me get started, and I will take the rest properties of scalar triple product in the upcoming classes. Okay, so let us try it and solve out some important question to illustrate whatever we have studied in today's lecture. So basically there is a question which relates the volume of the parallel pipe whose coterminous edges are given by u vector, v vector and w vector is such that this is 1 cubic unit. So from here it is given as the scalar triple product of this u vector, the v vector and w vector के जो वैल्यू है वो दे रखा है कितना, 1 दे रखा है. सो अगर क्वेश्चन में 1 दे रखा है एंड दिस वेक्टर्स आर रिप्रेजेंटेड इन टर्म्स ऑफ कंपोनेंट्स, देन वी डायरेक्टली गो एंड सॉल्व दिस इन फॉर्म ऑफ डिटर्मिनेंट. तो डिटर्मिनेंट अगर सॉल्व करेंगे, दिस इज 1 1 लैम्डा, दिस विल बी 1 1 3 over here, this will be 2 1 and 1 over here, and if I equate it to 1, and since volume का बात कर रहा है, because this particular result might give some positive or negative value, but then for incorporating that we'll put a modulus over here so that we get the positive value. Okay, we take the positive value. Okay, so if I solve this particular determinant along the first row, and the first row I will get 1 minus of 3 minus 1 times of, this will be 1 minus of 6 and plus of lambda times of 1 minus of 2, which is basically equal to plus minus 1. So from here if I solve, I will get minus of 2, from here it will be minus of minus 5, that is basically plus 5, and this I will get as minus of lambda is basically equal to plus minus 1. So from here you will get 3 minus lambda is basically equal to plus minus 1, that means it can be plus 1 or it can be minus 1. So from here the value of lambda, can be equal to 3 minus 1, that is basically 2, या फिर the value of lambda can be 3 plus 1, that is basically equal to 4. So the two possible values of lambda can be possible. So from there I can write the u vector as I cap plus j cap. Okay, I cap plus j cap plus 2 times of k cap. अगर I cap plus j cap plus 2 times of k cap है lambda का value for lambda is equal to 2. Now if I take lambda is equal to 2 and try to compute the another result that the question is actually asking is basically if theta is the angle, और जहाँ पर भी क्वेश्चन में एंगल का बात कर रहा होगा, that means we have to compute the dot product, and if it is talking about the angle which is between the edges u vector and w vector, that means I have to take dot product of these two vectors and compute the cos theta. So from here if I go on and solve this result as cos of theta is basically u dot w, और जहाँ पर लैम्डा का वैल्यू हमने 2 लिया है, ठीक है, तो डिवाइडेड बाय मॉड्यूलस ऑफ u इंटू मॉड्यूलस ऑफ w. सो इफ आई सॉल्व दिस एंड सिंस द जो वैल्यू ऑफ लैम्डा इज 2 है, सो इफ आई कंप्यूट u डॉट v, दैट इज बेसिकली 2 plus 1 plus 2. Okay, so from here I will get 2 plus 1 plus 2 when lambda is equal to 2. So and divided by, if I compute the modulus value of w, so if I compute the modulus of w, the result will be 2 square, that is 4 plus 1 plus 1, that is root 6, and similarly the value of u, modulus of u will be root 6 for lambda is equal to 2. For lambda is equal to 2, the modulus value of root u, that means the magnitude will be again be equal to root 6. So root 6 into root 6, that will be 6, and from here if you solve, this will be basically 5 by 6. So from here the cos theta value will be basically equal to 5 by 6. But if we look at the options, we do not get any particular option which matches, okay, which particular matches over here. So in that case we will solve for lambda is equal to 4. Okay, we will solve for lambda is equal to 4. Now if we solve for lambda is equal to 4, u vector is I cap plus j cap plus 4 times of k cap. Now the modulus, that means the magnitude of u vector will basically how much? This will basically be 18, root 18, and root 18 is basically root under 3 root 2. Okay, so in doing so, if I calculate the cos theta value, now in doing so I will get the result as u dot w divided by mod of u, that means the magnitude of u into magnitude of w. So from here the magnitude of u is 3 root 2 and magnitude w we already calculated, that is root 6, and the dot product will basically how much? That is 2 plus 1 plus 4. Okay, so 2 plus 1 plus 4 will be how much? This particular value will be 7 by 3 root 2 into 6. So from here if you compute the result, this will basically be 7 by 18 root 2. Okay, so this result comes out as 7 by 18 root 2. And if I take okay, so if I take over here 9, if I take 3 common, okay, 7 by, okay, if I take 3 inside, and I can write this as 6 into 3. So if I write it as 6 into 3, I can also compute this result as 6 into root 6. Okay, 6 into root 6 I can write, because this is root 6 over here. Okay, so since it was root 6 over here, that was my mistake I did over here. So from here I can write this as 3 into root 6. Okay, so if I have this particular result as 3 into root 6, okay, did I calculate it for right? Okay, I guess I have calculated right. 4 square is 16 plus 1 is basically 18. That means root under 18 is basically 9 into 2. So 9 into 3 root 2. So 3 root 2 into root 6. So from here, if you calculate, this is basically 3 into root 12. Okay, so from here this result will be, if I am solving over here, is 7 divided by 3 into root 12, and root 12 can be written in terms of root 6. Okay, so if I write in terms of root 6, then I can take a 2 over here and I can write it as 7 by 6 root 6. Okay, I can write this as 7 by 6 root 6. No, sorry, root 12 is given over here, so I can do 4 into 3, that means 2 will be taken out of, and 6 into root 3. Okay, 6 into root 3. Okay, so from here the result will be 6 into root 3, 7 divided by 6 into root 3. So if we check the option, this is basically the option number A, which basically satisfies this result. So from here the value of cos theta you get is basically 7 divided by 6 root 3. Okay, 6 root 3. So I hope this particular solution was clear. Okay, that very simple question that is actually asked in JEE Mains. You see, you are knowing the concept that how to calculate the volume is basically by the use of scalar triple product, then you can directly get to the result. Okay, I hope this particular thing is clear. Now let us move to the last question of today's lecture. Is basically it talks about coplanar conditions. So in this question it is said that there are 3 vectors, A vector, B vector and C vector, and these 3 vectors basically form a set of coplanar vectors for values of alpha. Now it has to relate with the values of alpha. ना ऐसा टाइप का क्वेश्चन भी JEE Mains में आता है, काफ़ी सिंपल होता है. डायरेक्टली अगर 3 वेक्टर दे रखा है एंड यू हैव टू रिलेट द रिजल्ट ऑफ कोप्लेनरिटी, यू विल डायरेक्टली आंख बंद करके ये वाला रिजल्ट अप्लाई कर देना, दैट इज स्केलर ट्रिपल प्रोडक्ट को जीरो कर देना, स्केलर ट्रिपल प्रोडक्ट को जीरो कर देना. एंड सिंस द स्केलर ट्रिपल प्रोडक्ट इज रिप्रेजेंट इन टर्म्स ऑफ कंपोनेंट, वी विल सॉल्व इट बाय यूज ऑफ डिटर्मिनेंट. सो फ्रॉम हियर अल्फा 1 and 3, so from there 2 1 and minus of alpha, from here alpha minus of 2 and 3 over here. Okay, if I solve this determinant and equal it to 0, so if I expand along the first row, I get 3 minus of 2 alpha, okay, minus 1 times of 3 plus alpha square, and plus 3 times of minus of 4 minus of alpha, which is equal to 0. So from here if you compute the result, this will be basically 3 alpha minus of 2 alpha square minus 3 minus of alpha square minus 12 minus of 3 alpha is equal to 0. So 3 alpha minus 3 alpha and plus 3 alpha get cancelled, and similarly this will be minus of 3 alpha square, which is equal to, if I take this on this particular side, it is equal to minus of 15. So from here the value of alpha square, this particular result is equal to 15. From here the result of alpha square is minus of 5. So is there any positive, is there any real number for which this particular relation exists? Because we already know for in real number the value of square is obviously a positive value greater than or equal to 0, where alpha belongs to real number. if alpha belongs to real number, then its square will be always be greater than or equal to 0. So in doing so, this particular equation, that alpha square is equal to minus of 5, has no roots. Okay, that means the set that the question talks about, the set S. The set S is basically an empty set. That means the set S is equal to 5. Okay, it is equal to 5, that is null set. So from here, the correct option to this question will be option number D. I hope this particular discussion is clear. Okay, so with this we come to the end of all the topics. Okay, so basically I am left out only with discussing about the remaining properties, remaining important properties. Okay, so I am left with talking about. So what is left in today's lecture is basically other important properties on scalar triple product. Other important properties on this particular box product or scalar triple product. Okay, and simultaneously we will start with the topic of vector triple product in the next class. Okay, so I hope this particular discussion is clear. So if you have understood all the particular concept which I have taken up in this particular lecture, and I hope you have taken up running notes. आप कॉपी बुक लेके बैठे थे और रफ में नोट्स लेते जा रहे हो, ठीक है. अगर नहीं कर रहे तो देन यू वोंट बी एबल टू अंडरस्टैंड व्हाट आई एम गोइंग ऑन एंड टीचिंग इन दिस पर्टिकुलर लेक्चर्स. ओके, अगर आप लेक्चर को अच्छा लगा होगा तो सब्सक्राइब टू माय चैनल. ओके, एंड इसके साथ आपका नोट्स भी मिल जाएगा डिस्क्रिप्शन बॉक्स में. सो गो चेक आउट द डिस्क्रिप्शन बॉक्स में नोट्स दे रखा है. उस नोट्स से जाके नोट्स बनाओ और क्वेश्चन को प्रैक्टिस आउट करो. जब तक क्वेश्चन प्रैक्टिस नहीं करोगे तब तक यू कैन नेवर हैव अ गुड कमांड ऑन द मैथमेटिक्स पोर्शन. जब भी मैथमेटिक्स का बात होता है ना, यू हैव टू प्रैक्टिस क्वेश्चन. और मैथमेटिक्स में हर एक चैप्टर में अगर 100 से 150 क्वेश्चन प्रैक्टिस करते हो ना, देन यू कैन डेफिनेटली क्रैक कोई भी टाइप का क्वेश्चन आपको क्रैक कर सकते हो. बट हाँ, यू हैव टू टेक वेराइटीज ऑफ क्वेश्चन. एक ही टाइप का क्वेश्चन बार बार प्रैक्टिस करने से कुछ नहीं होगा. डिफरेंट टाइप्स ऑफ क्वेश्चन को ट्राई आउट करो. ओके, डोंट ट्राई टू रिमेन इन द comfort zone. So I hope this particular discussion is clear, and if you like this particular video, do like and subscribe, and also share this video with the one who actually need this. These are basically free resources which are basically golden values and resources for all of you. I hope you will take the best benefit of these lectures, and with this I take and leave from this lecture. Thank you.